The science of tornadoes, understanding their formation, types, and impact. Tornadoes are one of nature's most powerful and destructive forces, capable of causing immense devastation in a matter of minutes. Understanding the science behind tornadoes is crucial not only for meteorologists but also for the public, as it can lead to better preparedness and response strategies. This article explores the formation of tornadoes, the various types that exist, their impact on communities, and advances in tornado research and forecasting. What are tornadoes? A tornado is a rapidly rotating column of air that extends from a thunderstorm to the ground. Tornadoes can vary in size, shape, and intensity, with wind speeds ranging from less than 100 miles per hour to over 300 miles per hour in the most extreme cases. The Enhanced Fujita (EF) scale categorizes tornadoes based on the damage they cause, ranging from EF0, weak, to EF5, incredible. Tornado formation, the meteorological process. Tornadoes form under specific atmospheric conditions, often associated with severe thunderstorms. The key factors that contribute to tornado formation include 1. Instability in the atmosphere. For a tornado to form, the atmosphere must be unstable. This occurs when warm, moist air near the surface rises into cooler, drier air aloft. The result is the development of thunderstorms, which can lead to supercells, powerful storm systems that often spawn tornadoes. 2. Wind shear. Wind shear refers to the change in wind speed and direction with height. This phenomenon is critical for tornado formation, as it can create a rotating updraft known as a mesocyclone. Wind shear is typically stronger in the presence of a frontal boundary, where warm and cold air masses meet. 3. Trigger mechanisms. Certain meteorological triggers can initiate the development of tornadoes. Common triggers include cold fronts. The collision of cold air with warm, moist air can lead to severe thunderstorm development. Orographic lifting. When air is forced over mountains or hills, it can cool and create conditions conducive to thunderstorms. The life cycle of a tornado. Tornadoes typically go through several stages in their life cycle. 1. Development. The initial stage of a tornado begins with the formation of a supercell thunderstorm. Within this storm, a rotating updraft develops, creating a mesocyclone. If conditions are favorable, this rotation can tighten and extend downward, forming a visible funnel cloud. 2. Mature stage. During the mature stage, the funnel cloud extends to the ground, resulting in a tornado. This is the most dangerous phase, as the tornado may cause extensive damage to structures and the landscape. The width of the tornado can vary, with some tornadoes measuring over a mile wide. 3. Dissipation. Eventually, tornadoes will weaken and dissipate. This process can occur gradually or suddenly, depending on changes in atmospheric conditions. The tornado may lift off the ground, leading to the eventual demise of the storm system. Types of tornadoes. Tornadoes can be classified into several categories based on their characteristics and the conditions under which they form. 1. Supercell tornadoes. Supercell tornadoes are the most powerful and destructive type, often associated with supercell thunderstorms. These tornadoes can last for extended periods and have the potential to produce EF4 and EF5 damage. Supercell tornadoes typically exhibit a well-defined structure and are often preceded by a rotating wall cloud. 2. Landspouts. Landspouts are weaker tornadoes that form from non-supercell thunderstorms. They often appear as a rotating column of dust or debris and can develop quickly. While they can still cause damage, landspouts are generally less intense than supercell tornadoes. 3. Waterspouts. Waterspouts are tornadoes that form over water. They can develop in similar conditions to landspouts and can occasionally move onto land, causing damage. Waterspouts are typically weaker than their land-based counterparts, but they can still pose a threat to boats and coastal areas. 4. Multivortex tornadoes. Multivortex tornadoes consist of multiple smaller vortices rotating around a central core. These tornadoes can cause significant damage due to their complex structure and are often associated with larger supercell tornadoes. The impact of tornadoes. The impact of tornadoes extends beyond immediate destruction. They can profoundly affect communities, economies, and ecosystems. Key areas of impact include 1. Destruction of property. Tornadoes can destroy homes, businesses, and infrastructure. The level of destruction depends on the tornado's intensity and path. EF5 tornadoes can obliterate well-built structures, leaving only debris behind. 2. Loss of life and injury. Tornadoes pose a significant risk to human life. Statistics indicate that fatalities can range from a few individuals in weaker tornadoes to hundreds in the most powerful storms. Injuries are also common, with many individuals requiring medical attention following a tornado event. 3. Economic impact. The economic consequences of tornadoes can be devastating. Rebuilding efforts can take years and may require substantial financial resources. Local businesses may suffer losses due to damage or decreased customer traffic during recovery periods. 4. Disruption of communities. Tornadoes can displace entire communities, forcing residents to evacuate and find temporary housing. The psychological impact of such disasters can lead to long-term emotional distress for survivors, necessitating mental health support and community resources. Advances in tornado research and forecasting. Scientific research into tornadoes has advanced significantly over the years, leading to improved forecasting and response strategies. Key developments include 1. Improved radar technology. Doppler radar has revolutionized tornado detection and monitoring. This technology allows meteorologists to observe wind patterns within storms, helping to identify potential tornado formation. Dual polarization radar technology enhances the ability to detect debris within tornadoes, improving warning accuracy. 2. Storm chasing and data collection. Storm chasers play a crucial role in tornado research. By capturing real-time data and footage, they provide valuable information about tornado behavior and dynamics. This data contributes to a better understanding of tornado formation and characteristics. 3. Modeling and simulation. Meteorologists use sophisticated computer models to simulate tornado conditions and predict storm behavior. These models incorporate various atmospheric variables, enhancing the accuracy of forecasts and warnings. 4. Public awareness campaigns. Effective public awareness campaigns educate communities about tornado preparedness and safety measures. Initiatives often include tornado drills, informational materials, and outreach programs aimed at improving understanding and readiness. Tornado preparedness, essential steps for safety. Being prepared for a tornado can save lives and minimize damage. Here are essential steps individuals and communities can take. 1. Create a family emergency plan. Identify safe locations. Determine the safest place in your home for tornado shelter, e.g., basement or interior room. Establish communication plans. Create a system for family members to communicate during a tornado event. 2. Build an emergency kit. Essential supplies include non-perishable food, water, first aid supplies, flashlights, batteries, and a weather radio. Important documents. Keep copies of important documents, insurance, identification, in your emergency kit. 3. Stay informed. Monitor weather alerts. Use weather apps, know our weather radio, and local news to stay updated on severe weather alerts. Learn the signs. Familiarize yourself with the signs of an approaching tornado, such as dark, greenish skies, large hail, or an unusual calm before a storm. 4. Participate in community drills. Engage in local tornado drills to ensure that you and your family are prepared for an emergency. These drills help reinforce the importance of seeking shelter quickly. Conclusion. Tornadoes are complex meteorological phenomena that pose significant risks to life and property. Understanding their formation, types, and impacts is essential for effective preparedness and response. Advances in research and technology have improved tornado forecasting and public awareness, enhancing communities' ability to respond to these powerful storms. By staying informed and prepared, individuals and families can significantly increase their chances of surviving a tornado and recovering from its impacts. As climate change continues to influence weather patterns, ongoing research and education will be crucial in mitigating the risks associated with tornadoes and ensuring community resilience in the face of these formidable forces of nature.